Good morning, everyone. Today we are going to go through the past paper question for topic 14.1 and 14.2, properties of acids and alkalis, and also neutralization. These are the past paper questions from SPE, and they're compiled by SBC Brunei. Please remember to write down your name, your class, and the date. Okay, let's do question number 1. A science teacher told Aisha that orange juice is acidic. She extracted some orange juice and carried out some tests. Which of the following tests confirms her teacher's statement? So the keywords here is acidic and confirmation. So what you need to know here is the properties of acids. And when we talk about confirm, it means that the test should show it's an acid and nothing else. So let's go for the first one. The orange juice turns blue, litmus paper red. That is actually a property of an acid. So acids turn blue litmus paper to red. The orange juice has no effect on red litmus paper. We know that it changes the litmus paper from blue to red, but if we add an acid to a red litmus paper, it wouldn't change. So this is still it is a true statement, but it doesn't show us that it's an acid, and we need something to really show us that. So this is not an option. This is a strong option here. And let's check out C. The orange juice has no effect on blue litmus paper. That's incorrect because it does. It changes it from blue to red. The orange juice turns red litmus paper blue. This is incorrect because this is a property of an alkali. The answer here is A. The figure below shows a description of a mysterious substance found in the science laboratory. Which of the following matches this description? Bitter taste, turns red litmus paper blue, slippery. So this all points out to an alkali. Common salt is just salt, S-A-L-T, and lemon juice is an acid. Soap is an alkali, and vinegar is also an acid. So here, the only answer here, we're looking for alkali, and the only alkali you can find is C, so the answer is C. A science teacher told Kasim that hand washing liquid is alkaline. So I think we're looking at properties here as well. Kasim poured hand washing liquid in a beaker and carried out some tests. Which of the following tests again confirms? So this has to really show that it is alkaline. The soap has no effect on blue litmus paper. So with litmus paper, what alkaline solutions do is that it will react with red litmus paper and turn it blue. But if you add it to blue, of course, there won't be an effect, but this doesn't show that it's alkaline at all. So it's a no. Soap has not, I think it says no, has no effect on wet red litmus paper. This is incorrect because it should turn it from red to blue. The soap turns wet blue litmus paper red. This is a yes. And the soap turns red litmus paper blue. Oh, sorry. This is incorrect. This is an acid. Answer should be D, which is red to blue. The only one here that shows a property of an alkaline. Okay, next question. The best condition for a fish to live is when the pH of the water of the lake is neutral. Neutral is pH 7 only. A group of students tested a sample of water from a lake using 3 indicators, and is shown in this picture here. Not a picture, but a table here. So there's indicator 1, 2, and 3. The only one that you are familiar with is actually litmus. Bromothymol blue and phenolphthalein, you don't really talk about this or learn about this, but it tells you already what kind of ranges, like what kind of reactions they have when it's exposed to acids, when it's neutral, and when it's exposed to alkalis. So here are the test results when this guy, what was his name again? Oh no, it's not a guy, but a group of students. What they found out was the lake water, and when they tested with bromothymol blue, it turned yellow. So yellow here means that it is acidic. Litmus here turned red, so it also shows that it is acidic. Phenolphthalein is colorless, and when it comes to colorless here, it means that it is either neutral or acidic. What can be concluded from the results above? So we know that we want pH 7 for the fish to live, and pH 7 is neutral, but we can see that from the test most of it is actually leaning towards acidic. We don't know if it is actually acidic or neutral, because for phenolphthalein it's colorless both in acidic and neutral environments, but most of the results seem like it's pointing towards acidic, so it's actually no, it's not suitable. The reason for this, so looking at the options, indicator test showed water in the lake is acidic, or the other one says it's alkaline, but we can see that it's more towards acidic, so the answer here is A. Which of these statements about pH is true? So pH is a measure of how acidic or how alkaline a solution is. Usually I think it's around, starts from 1 and then 14, and then you have 7 in the middle. So from neutral towards the left here, that's acidic. The lower the number is, the more acidic or stronger it gets. And the more closer it is to 7, the weaker the acid is. And for alkaline solutions, the more it is, the higher it is from or away from 7, that's strong alkaline. The closer it is to neutral, it's a weak alkaline solution. So which one of this is true? At pH 1, strong alkali, that's incorrect. You can see here that pH 14 is a strong alkali. At pH 6, the solution is a strong acid, but it's closer to neutral right here. So it's actually a weak acid, so that's incorrect. At pH 7, the solution is neutral, that is correct. pH 14 here is a strong acid, that's incorrect. It's actually a strong alkali. So the answer here is C. Study the experimental result below. It shows the color of universal indicators of a solution with 5 different pH. Using the above information, predict what would be observed if orange juice and soap solution is tested. So orange juice is actually a weak acid. It should be, I think, around yellow right here. And soap is actually a pretty strong alkali. So I would go, I think, purple. So do we have yellow and purple for orange juice? Yep. So yellow, and then we'll go for purple. D. But let's have a check. So this is, let me just check again for that question. My major is actually biology, and I'm more comfortable actually teaching biology, but of course I should get my basics of science pretty well as well. Okay, so you can see here, okay, so soap is around 12 to 14, but the option that we had just now was 10 and 14, so I would go for pH 14, which is purple for soap. So we're gonna stick with the answer D. Question number 7. The chart in the figure below shows the color of indicator P at different pH values. So we don't know what this indicator is, but it shows you the color changes that it has. What will be the color? What will be the color of indication P if you're looking at a solution with a pH 5? So let's look at pH 5. Okay, so 1, 2, 3, 4, 5. So it's around here, and it says right there it's yellow. So the answer here is yellow, D for yellow. Question number 8. Acids and alkali are commonly used in our daily lives. Complete the table below to show the properties. So here is again properties of sodium hydroxide is an alkali. The taste should be bitter. Feel when touched, slippery or soapy. Up to you. pH should be greater than 7 or around pH 14. One common use is to make soap. There are other common uses, so let's have a look at our notes right here. To make soap detergent, making plastic, sodium salt, which is table salt, to neutralize acids, and removing paint and grease. Okay, now we're moving on to neutralization. When sulfuric acid is added to sodium hydroxide, hydrogen is produced. This is a trick question. This is actually false. To make hydrogen, what you need is you need to add an acid plus a metal. And then you get a metal salt plus hydrogen gas. But when you add an acid plus an alkali, you're actually going to get a salt plus water. And this process is called neutralization. Neutralization reaction always produces salt and water, and that is true, and we just showed it just now, so the answer is true. Question number 3, figure below shows the steps Nur Huda needs to take to investigate the changes in pH during neutralization. The steps are shown below are not in order, so we need to put them in order. Okay. Add 2 drops of pH indicator solution to the flask. This one should be the last step. So let's look at the first step. I would say drawing out the solution should be the first step, because you want to take it out, so the sodium hydroxide, with a syringe first. So I think they use a syringe so that they do not contaminate the product, but remember to always don't reuse the syringe with other solutions. Then you put 10 cm cube of that. So from the syringe, you put it into a conical flask. So that will be the second step. Next step, you add your acid. So that is the neutralization process. And then lastly, finally, you check the pH indicator. That should be the last step. So it's 2, 3, 4, and 1. 2, 3, 4, 1. The answer is B. The chart in the figure below shows the color of some indicators at different pH values. Which indicators are suitable for a reaction between acid and alkali? So what is pretty important here, I think, is that you need to, I guess, have a distinction between what's an acid and what's an alkali. So the only two indicators that kind of show that difference is the stark difference between acid and alkali here is W and Y. You can see that above 7 the color is red and below 7 it's yellow, and then if it is above 7 for W it's blue and yellow as well. So the answer, we agree, is D. Fathinidis added some HCl, hydrochloric acid, into sodium hydroxide solution until it became neutral. Then she added some more acid. So what happened here is that, we have pH 1 and pH 14. And pH 7 is in the middle. So what happened was when Fathinidis added the HCl to sodium hydroxide, it's going to be at pH 7, so right here. But then she added more acid. So I added more acid, that means it's going to move towards the left hand side. And the final pH here, so it wouldn't be pH 7 because they added more acid afterwards, wouldn't turn more alkaline, so it shouldn't be these. The answer is A. That's the most plausible answer. Question number 6. Which one of the following shown in the table correctly explains what causes indigestion? So indigestion happens when you have, so this right here is the esophagus. I think you call it the gullet in primary school. And then it's connected to the bean-shaped organ, which is the stomach. So in your stomach you actually have an acid already called hydrochloric acid, and this HCl can actually come up and that'll cause this burning sensation, and you call that heartburn. So what happens, why is it painful, is actually because of the acid coming up. An antacid is actually, I would explain it as anti-acid. That's how I remember it. This means that it's the opposite. So an antacid should be an alkali to reduce the effect of that acid. So what causes indigestion is actually too much acid in the stomach. And what antacid, because they're alkali, what they do is that they help to neutralize the acid. So the answer is A. Acids and alkalis are commonly used in our daily lives. Acids react with alkali. Name the process when acid react with alkali. This is called, oopsie, okay, let me just get my pen in order again. Okay, this is called Neutralization. Explain why bee sting would get more painful if you apply vinegar on it. So vinegar is actually an acid. So let me bring you back to that slide. So ethanoic acid, if you can see over here, one of the uses is for cooking, and it actually makes vinegar. And as for the bee sting, so it's neutralization part 2. So if you look over here, here, treatment of insect bites. Baking powder as an alkali can help to neutralize the bee sting and ants bite. So what happens is that insects have formic acid, and that helps, not helps, but it makes this painful thing. So what we need is actually an alkali, not an acid. So vinegar is acidic, and that would be the answer for it. So you can say a bee sting contains if you don't remember the name of the acid, you can just say that it contains acid. Because both of them are acidic, then the pain would be much more stronger, because the effect of the acid will be stronger when you add acid to an acid. Okay, farmers add lime calcium oxide to the soil. Explain why. Lime calcium oxide is a product. So let's go back to that slide as well. Just this one, I think. Okay, here. It is made up of, I think it comes from calcium hydroxide. So you want to help to reduce soil acidity. So why do you add it to soil? To reduce soil acidity. If the soil is too acidic, then the plants can't grow very well. Okay, the figure below shows sodium hydroxide solution being added to dilute sulfuric acid in a conical flask. What is the color of dilute sulfuric acid? It says here the color of, and remember that acids are actually colorless. Until you add an indicator, then it can have a color. Okay, so now, if a few drops of universal indicator solution was added to dilute sulfuric acid, what would be the color? So it would be red. Let's go and have a look if I actually have it somewhere here. Not too sure if I showed the, okay, here. Yep. So it is, it does say that it is dilute. So maybe instead of very acidic, maybe around orange to red, maybe. I would say red, but maybe orange to red. Okay, sodium hydroxide solution reacts with a dilute sulfuric acid in the conical flask to form X. So solution X is a salt obtained after the reaction has been completed. So remember that this is a neutralization reaction. So let's follow this one first. Sodium hydroxide plus then you draw an arrow, then the salt formed would be sodium sulfate. Plus water. Okay, so how does these Okay, here we go. So how do you name salts after neutralization? Firstly, let's look at neutralization. It's the process where you get acid plus alkali, then you get salt plus water. So the name of the salts, you look at the acid part. If it's sulfuric acid, it's called a sulfate. And what you do is that the salts are named after the acids that they are formed. So you take the first name of the alkali, and then the last name would be the acid. So here's sodium sulfate, and don't forget to plus water as well. Name this type of reaction. It's called a neutralization reaction. Oh, actually, this is the answer for anti-D. It's actually sodium sulfate. So let me erase that. I think I got carried away because I remember during this question. I'm really sorry about that. Okay, so this is actually sodium sulfate. And the word equation is what I've written down just now, which is sodium hydroxide plus dilute plus water. Briefly explain how you would be able to get a pure solid sample from this reaction, and let me get back to that. Okay, here. So how do you do it actually? You get an acid and an alkali, and then you mix it up together. But what you can do is that when you get that salt solution, you can put it onto an evaporating dish, and then you heat it up until all the water is evaporated, and then you get a solid salt. So how do you explain this? So you just say you add or place, I guess, or transfer. So transfer maybe is a good word. I think heat the solution would be better. Heat the mixture. Okay, I think mixture is a good word. Okay, there you go. Transfer the salt solution into an evaporating dish. You heat the mixture until all water has evaporated, leaving the solid salt. The word equation P and Q shows two reactions: hydrochloric acid plus sodium hydroxide. So this one here is an acid plus an alkali. So what you should get is your salt here plus, so the answer here is water. It says here to complete the word equation by writing the name of the product formed in P and Q. So you write down the name here. So you should write down water down here. Okay, this is just for your notes, by the way. Like when you're writing in an exam, remember to write down little notes here and there to kind of organize your thoughts. But make sure to write down the answer in blue or black ink in the answer space provided. Here you have acid plus a salt. So when you add acid to salt, you actually get a metal. So here magnesium is a metal, salt plus hydrogen. So this is a process of making hydrogen. So Q here refers to hydrogen. A few drops of universal indicator solution are added to the alkali in reaction P right here, and say the color change. So here it asks for a color change. That means from something to something else. So the color change would be from colorless to, so the solution was colorless at first, right? But when you add an alkali, a really strong one, it's gonna go purple. So colorless to purple. Otherwise, to write down colorless to purple. When we spell color, the British system is with a U, but for American system is color. We are following a British education system, so let's use the U here. Describe a test to identify the product form in reaction P. Reaction P is water, so what we can do with that is we can use dry blue cobalt chloride paper. So this is actually referring to your test of gases information. Reaction Q, remember, is about hydrogen being formed, and so for hydrogen you actually use a burning splint. The glowing splint is for oxygen, test for oxygen. Burning splint is for hydrogen, and hydrogen gas is not found in the air because it's very, very highly flammable, and you're gonna get an explosion. So if you have a burning splint, a pop sound, that's a small explosion, will be heard. Is present. So remember, burning splints. Okay, so I think that is the end. I hope that you finished this past paper for this week. I'm gonna give you another past paper. I think the topic gases for next week. Okay, have a good day, everyone. Thank you for watching.